Here children, first had studied the chapter electricity, and now we are going to study about the effect of electricity. In the first effect of electricity which we are going to discuss today is the heating effect of electricity. So you might have seen a lot of electrical devices which convert electrical energy to heat energy. Like, you know, during the winter you've got the heater. You must be having a glowing rod when in winter season, when the old people, they are around it and they are taking the service of that heater. Or you must be having an electrical iron at home, or you may be having a geyser at home, or might be an immersion rod. And then if you go to the saloons, you'll find the saloon person is using something, a very circular thing with wires in it, and just he puts in the plug and he puts down the that device, a circular, you know, disc in water, and after some times the water gets warm. So all these things, these devices use the heating effect of current. So, or electricity actually, heating effect of electricity. So why does a particular device gets heated up, or why does a particular wire gets heated up? Also, you may be watching that whenever you are using a mobiles, you know, after some time of use, you see it gets heated up, or a TV running, it gets heated up. It's just because electricity flowing through these devices, through the wires, through the conductors. When electricity flows, actually the electrons flow, and when the electron flow, the make of the particular material, it may contain atoms, molecules, etc., which prevent or resist the electron to flow smoothly, and therefore there is heat generated in that. So you just see, you can imagine, no, when electrons are moving, and then they're hitting the molecules, and they get heated up, and that's why certain wires get heated up. But then there are certain wires which get heated up to a lesser extent. There are certain wires which get heated up to a greater extent. Also, the devices, when they heat up, some devices will get your water warm very fast, like geysers. The immersion rod will take a little bit more time, and whereas the disc which the saloon fellow in a very simple saloon they're using, then that will take much time. So all these things are hidden in our discussion today. Number one, the heating effect of electrical current. So the heat produced when current is moving depends on current, that is I, and heat is proportional to the square of current. The heat produced in a conductor when current is flowing, it is proportional to the square of current. It is directly proportional to the square of current. That means through this wire, if current is flowing, so the quantity of current will decide how much of heat is produced, number one. Now, this is a relationship, and therefore we have to talk it in terms of relations. That means, suppose there was 5 amperes of current flowing, and this was getting upheated to somewhat like 10 joules. When 5 ampere of current was flowing, then it was getting heated up, and then 10 joules of heat was being produced or noticed or recorded in this conductor. And then now let us see, we change the electrical source and we pass on more current, we double the current. That means now 10 ampere of current is flowing. That means current has doubled. So what will happen to the heat now? So see, heat is directly proportional to the square of current. That means the change which you have brought is 2 times, isn't it? You have brought 2 times. Current has increased 2 times, then heat will be increasing, the square of the current increase. That means it will be 4 times now. So when we had 10 joules, now we have 4 times more. So the heat produced will be 40 joules. So this is what you have to keep in your mind. So this is what an electrical geyser does. An electrical geyser, when it is kept in your, when it is fixed somewhere in your house, and then what happens, it is a device which is costly, because what happens, the current which is flowing in your houses, these are normally 5 ampere to 15 ampere. When it reaches to your geyser, inside there is a device which will increase the current, might be 5 times, and then the heat will be 5 square, that is 25 more times that particular conductor will heat through which which is kept inside the geyser, and that heat will heat the water very fast. So that is there. That means, again, let me talk once more about this. If the current increases triple, that means it becomes 15 ampere, then 3 times increase. Is the current increases 3 times, then what happens? Then the heat is increased 3 square 9 times. Now heat is also directly proportional to the resistance. So this is also very simple. That means, now suppose I keep the current fixed, I am not so rich to buy a geyser, then I'll buy an immersion rod. So when we buy an immersion rod, that immersion rod, what does it do? It is actually, it contains wire which is more than the normal length, and probably its nature is that it will get heated little more than the usual conductors. Its resistance will be little higher. So, and when you increase the length, the resistance increases. So if you suppose you've got a wire, say for example, whose resistance is now 5 ohms, and you increase the resistance to 10 ohms, then suppose it was heated 12 joule, it will heat 2 times only. That means the times by which the resistance increases, the same times the heat produced will increase. So 5 2s are 10, 12 2s are 24. So it is directly proportional. Then also, now what happens to my son, when I go out and come back, I will watch him studying and his mobile kept sideways. His name is Sachin. So when I'll ask him what were you doing, he will tell he was studying for the last 2 hours. But when I go and put my hands on his mobile, I saw it's heated up, though it's off. That means he was using the mobile for quite some time. And heat produced is directly proportional to the time span for which the current flows through the conductor. And therefore, heat, if we use all the 3 proportionality, we can get H is equal to I square RT. This has to be remembered by you, number 1. So we can also get this equation once again if we remember the formulas being used in this whole chapter. What was the first formula which we studied in this chapter was some formulas I'm going to write. Q is equal to NE, I is equal to Q by T, isn't it? And that tells you I is equal to Q by T, so Q is equal to IT, and also V is equal to IR. Electrical work done, during the definition of potential we studied, electrical work done is equal to change in potential into charge in coulombs. So these are the formulas which we really studied during this chapter. So now I take out this the work done relationship with electric potential. I just rub off the board a little bit. I need some board space. I leave this as it is. Rest of the things I rub off. And let us see, children. I take up W is equal to W work done. That means I tell it electrical work done. No? Electrical work done. Electrical work done is equal to potential difference, that is voltage, into charge in coulomb. But whatever work done in 9th, we said if it is being used for heat production, so the work done can also be said as the heat produced. So heat produced is equal to VQ. This is the first equation which you can keep it in your pocket to use at times. Second, H is equal to VQ is equal to IT. So I put Q is equal to IT. This is the second equation which you can use for yourself. Then third is V is equal to IR, isn't it? V is equal to IR by Ohm's law, Ohm's equation. So IR and one more I over here, so I square RT. However, if you wanted to change I as V by R, then heat produced will be equal to V square by R into T. See, V is here and I is equal to V by R, Sachin, so V square by R RT. So these few equations are very handy, though if you know these things you can always get to these equations by on your own by trying to place in the formulas used from here to this here. So see, we are getting the same thing, heat produced is equal to I square RT. So that is what is there, and you know all these things are the same. The equation for heat produced, but heat is a form of energy, so energy consumed is also equal to I square RT, and electrical work done is also equal to I square RT. These we can use. Thanks a lot, children. So I hopefully you have studied and these therefore once more I want to tell you, when a geyser is being used, then heat produced is directly proportional to the square of the current. So the current might have been increased much more than the resistance. In immersion rod the resistance is increased, and therefore the heat produced is there, but it is little slower than the geyser. So an immersion rod heats a little slower than the geyser. Same thing is that even your own any electrical device, if you keep on using it for a long time, then it will get heated, because heat produced is also directly proportional to the time span for which the current flows. I just will end it with a very simple use of it. There are sometimes people working at home and you're out, and say for example your housekeeper tells that he was working for last 2 hours. When you are standing at the door and you're knocking, you came back home after 2 hours and you press the bell, but you can hear the TV sound, but the housekeeper takes some time to open the door, and then when you get in, then you see he's having the broom in the hand and he's cleaning the floor. But then you quietly slyly go to the TV and touch it. It must be heated if he was watching the TV, because through any electrical device, if the current flows, it has to be heated. Thank you.